the objectives of a particular test. For example, by adding materials, you can make something drip, which removes it from the test zone. In some cases, this is very good fire science, and it removes the material from the heat source, which of course will stop a fire. In other cases, you could have drips which transfer the heat or transfer the material closer to the heat source, which cause worse problems. So it is also scenario dependent. Ultimately, we get to performance-based design, where people are trying to take a more engineered approach to look at how much of which material might be satisfactory in a particular environment, rather than just saying this material passed the test, this material fails the test. We should now be on areas of fire testing, where we've got a small map, and I was hoping to point this through with you. Fire testing can be divided into fire resistance testing, where we're looking at the structural integrity of components. Now, in the old times, that was really the structural integrity of steel in steel frame buildings before it softened and collapsed. But now, with composite materials, we find that aircraft are made of carbon fiber essentially flammable materials, carbon fiber shells, and therefore we have to consider the fire resistance of flammable materials too. But we're looking at whether they have the structural integrity during a fire, so whether they're softening and weakening, as well as their reaction to fire, which is essentially looking at issues such as their flammability or the toxicity of the fire gases. And both of those can be applied to anything in a continuum, really, between materials and products. Now, the division between materials and products is somewhat artificial. If you're the final seller, then I suppose it's a product, whatever